The strange graphics of Lethal Company. That is very interesting to me because I would like to know how he did it. I'm pretty sure it is a graphics filter from Unity. And you can see that the polygons are not that detail rich, right? He doesn't have many polygons to display what he needs to display. And that just again goes to show how it's not really that important how your game looks. Now, obviously, it's a distinct look, toon shader, something, right? And so Acerola is going to explain us how these graphics are actually made. Something I wanted to watch for a while now. So let's see. Because after I'm done with my game, I will do a 3D game.
Hello everyone! Lethal Company is a game praised by many for its horror, comedy.
Okay, bro. Does look like a horror game, man.
Oh shit.
Oh my god, this is more like a horror game, man. Holy shit.
And of course, its unique visual style.
I never
Surely
played
a game
it, by the
that
way.
looks this interesting must have lots of proprietary shader tricks involved. But no, nearly all the shader effects you see come pre-packaged with the Unity engine. So today, let's figure out how you could make the graphics of Lethal Company.
He just made a pre-packaged one. Awesome. You'll use Unity? No, I won't use Unity. We'll make it
Let's
in C++.
start with a simple visual study of a Lethal Company screenshot to get some idea of what's going on. You might hear a lot of words you're not familiar with, but don't worry, everything will be explained in detail later. The first thing you might notice is the dense fog. Everything a short distance from the camera begins to fade into a more homogeneous color, obscuring details.
No, he's not showing that. Wait, but here, you can see the fog starting here and the fog starting, I think, here. This must be the fog, right? And then, yeah, I guess this is also the fog, yeah, from the mountains. Looks a bit odd, but okay, yeah.
Short distance from the camera begins to fade into a more homogeneous color, obscuring details. We know this isn't fake fog because of these god rays in the shadow of the piping, making this legitimate volumetric lighting and not just fake distance fog. It's even more obvious if we look at these spotlights. Without the volumetric light simulation, then we wouldn't see these cones of light. The next most obvious thing is that something strange is going on with the light surface interactions. A point appears to be either fully lit or fully in shadow, with no gradient or anything in between. This could be a lot of different techniques, but no matter what, some quantization is being used here to reduce the amount of values used to color objects.
Quantization basically means reduce colors used. Okay, I get it now.
Going on here, but it seems to be that edges are only visible close to the camera. You can see the edge here on the cliff, but no edges on the rocks in the distance. Then there's this blurry helmet obscuring parts of the screen.
Oh wait, what? This guy's way too fast. Holy shit. This is the edge here. It looks like pixel art, by the way. It's really cool. It looks actually like pixel art. Damn, that's nice. Just noticed.
Edges on the rocks in the distance.
Good morning.
Then there's this blurry helmet obscuring parts of the screen. This could potentially be a simple post-processing effect, but that is to be determined. Next we have the low resolution.
I'm pretty sure that's just a post-processing effect drawn on top of the final image. So you have the final image, and then you just draw, could even be a sprite on top of that, bloop, in black.
The entire image. It's clearly being upscaled from a lower resolution because everything is kind of low quality. Lastly, we have every gamer's favorite effect, bloom, most obviously on the rocks here because the bloom bleeds onto the shadows. Here's another example of the bloom.
Yeah, bloom is awesome, by the way. I love bloom. If done correctly, bloom's really nice. And this gives the impression of something being lit by the sun. Really nice.
Bloom blobs. That's about everything. We can also assume...
Guys, just take a look at all of these things that you can do. Like, some of you might think, oh, Lethal Company, easy graphics in a game. Look at all of the different things that you do to make the game look like shit. It's basically, it's a unique art style, right? It's an art style. Hey, thank you very much for rating, Rexar. Thank you guys, welcome. Linux guy himself. Oh, it's the Linux guy. Oh, hello there. You went into a Windows territory here. I'm a Windows main, and I enjoy it. Yeah.
The usual color correction.
We're taking a look at the color correction. Yeah, but look at all of these things that you have to do in order to make your game look the way it looks, right? So it's not just you have your model and you draw it in the world. No, you also do all of these things together. And let's say you make your own engine. Let's say volumetric lighting could take you like a week if you're slow, right? Could take you a week.
Like exposure and gamma, but it's hard to say how exactly those are being used without more information. But Isrola, what about those clouds up there? Oh, that's just like a skybox yoinked from Google Street View or something. I don't know. Anyways, we can theory craft about these shader effects all day if we want, thinking about what order they are used in or whatever, or we could just use this handy dandy program to frame capture the game.
This is like RenderDoc, by the way. That's what I use. NVIDIA Insight does the same thing. If you have an NVIDIA graphics card, but RenderDoc does the same thing as well. So that we can see all the details
that go into how it was rendered. The same method I used to get info about the Counter-Strike 2 smoke grenades. But first, something a little different. This video is sponsored by Skillshare. Skillshare is the largest online learning community for creatives with thousands of classes led by actual industry professionals across all disciplines like programming, illustration, business, music, culinary, and many more. Skillshare is the perfect platform to get which immediate I found no brain. Everything skill to use my... Now, back to Lethal Company. If you're unfamiliar with what a frame capture is, essentially this program captures all the graphics API calls that were made by the game. For instance, when the GPU is told to draw an object, then the program will capture that, and then we can completely reconstruct the frame by executing those same exact API calls in order again. This particular capture needs 16,000 API calls to draw the frame, and we can see the details of...
The reason why that's so many is not because the game is so complex, but that's just because Unity is written in that way. Okay, so let me tell you that you don't need that many API calls if you were to make it yourself, okay? That's just Unity, all right? Now, obviously, these have like less than sub than 0.01001 milliseconds in terms of speed. In terms of how long they take, but still, man, you know, set vertex buffer, set vertex buffer, set vertex buffers. This can be optimized like crazy.
Each and every one. In addition, NVIDIA Insight does a full GPU memory dump so that we can use all the same assets like 3D models, textures, and decompiled shaders. This is how I know Lethal Company is made with Unity, because the names of the shaders in each pass follow Unity's Shader Lab naming convention, where the editor will sort the shader into categories based on the slashes. For instance, this shader is in the hidden category, so it won't show up in the Unity editor, and it's part of the HDRP shaders. This means Lethal Company is using Unity's high-definition rendering pipeline, the same rendering backend used by the recently controversial Cities Skylines 2. If you aren't chronically online, Cities Skylines 2 released with terrible performance issues.
Cities Skylines 2 is terribly... Wait.
If you aren't chronically online, Cities Skylines...
I'm not chronically online. How is the performance of Cities Skylines 2 even acceptable? Oh, Unity games. You guys just saw why it is that bad. You saw all of those API calls? Set vertex buffer. That's why. I'm running at a 390, 1440p, and most settings at high. Brand new map. It's 26 FPS, and they're charging. And we're praising them for being transparent and only charging $60. Cities Skylines 2 promises performance issues can and will be fixed. Ah, that's a big promise, bro. I want to see you try that. Okay. Terribly optimized, reporting less than 20 FPS and just... You guys are complaining about my 800 FPS in my menu? Look at these guys, 20 FPS in their menu. Huh? So who's laughing now? The performance target is to run at a steady 30 FPS. The developers. You can't sell that, especially not on a computer. You can't target 30 FPS on a computer. Are you stupid? What? Is Cities Skylines a console game? Guys, is Cities Skylines a console or a PC game? Is it like made for consoles first and then for PC second? Both? Yeah, both. We just don't believe there would be a long-term benefit in setting the target to 60 FPS. Yeah, okay, bro. We believe. Oh my god, these guys are... Oh my god, these guys are idiots. Holy shit, man. Anyone actually buys that?
2 released with terrible performance issues. Even 40 series cards were struggling to get real-time frame rates.
What?
A big reason why the performance is so bad is because HDRP isn't really meant to have good performance. Its shader effects are extremely expensive and meant to give the best visual.
We saw that video 5 years ago. That came out 5 years ago, by the way.
Possible, hence the name. Lethal Company runs very fast though. On my mid-range PC, it's clearing 100
It's made by GigaChat, one developer.
FPS without any issues. So why is it so much faster than City Skylines 2? Well, the reasons for that are endless, but a big one is that Lethal Company is actually rendered at a very small resolution. If we take a look at the viewport details in the profiler, it's 860 by 520, not 1920 by 1080 like...
Wait. I'm interested in that. Where's the calculator? So let's say we have a calculator, right? Let's say the default screen size is always 1920 by 1080, right? So what would we do to get to, well, what if we divide this by 2? That's still not 860. That's a weird scaling. Why is it scaled that way? If we go from 860, right? How would we get to 1920? Whoops. That's like 2.2. That's odd. It doesn't depend. No, listen, guys. Listen. If you have a smaller image and you scale it up when you're trying to achieve a pixel art effect, I guess he's not trying to achieve that. You would like, and 1920 is the most common resolution, you would like it to be a full value times 2, times 3, times 4. You don't want it to be 2.2 because then you get squashed pixels. He's not trying to do pixel grid effect, but this does look like it in kind of a way.
It's 860 by 520, not 1920 by 1080 like it should be if it were rendering at my full native resolution. 860 by 520 is a really strange number. Normally if a game is rendering at a lower target resolution, then it's some sort of factor of the native resolution.
Exactly.
For instance, I'm at 1080p, I would render at some smaller 16 by 9 resolution so that it cleanly upscales into my native resolution. Lethal Company doesn't do this. It renders at a fixed 860 by 520 regardless of the native resolution you're playing at, meaning that the image gets warped depending on the monitor you play with.
Exactly.
In our case, the image is going to be warped horizontally to fill the space. This is one of the main reasons why Lethal Company looks a bit strange. It's also why the game is so pixelated and low quality. If you play at 1440p or 4K, then this low quality aesthetic is going to be significantly more pronounced. But this strikes one mystery off the list. The game looks low quality because it's actually low quality. It's not faked with a shader effect.
Cool.
This has the added benefit of making the entire game extremely cheap. Lowering the target resolution of expensive HDRP shaders makes them way less expensive.
Yeah, you have to do less
let's take a look at this
not less
frame from the beginning. The frame starts with drawing
through.
all the objects in view. Annoyingly, Unity renders games upside down for whatever reason, so I'll be turning it right side up for your viewing convenience.
Yeah, this is probably because OpenGL used to be upside down, and so they render upside down and then flip. I think. Could be wrong though.
You can thank me over on Patreon.
Probably
as
something
usual,
with
a huge
OpenGL
thank you
to
to all my current patrons. Without your support, I wouldn't be able to take the time to rotate the video 180 degrees. You might be wondering why the objects have such strange colors instead of being drawn fully lit and colored like you're used to. Real-time rendering has two main tech trees, forward and deferred. Forward rendering is how you would intuitively think a game is rendered. When we draw an object, then we do all the lighting and coloring calculations immediately and write the output to the back buffer. Deferred rendering is a bit different. Instead, when we draw an object, we write all sorts of information about it to something called the G buffer. You might think that stands for graphics buffer, but no, it stands for geometry buffer. Obviously, this info we write is stuff like the normal vector or anything else we could possibly want for later. Then, during post-processing, we do all of our lighting calculations based on what was written in the G buffer. Mostly everything in the game dev world has used deferred, although in reality it's some unethical Frankenstein monster of the two. Lethal Company does not stray from the pack and also makes use of deferred rendering, which is why we are seeing the data that is being written.
What do we have? SS buffer, normal buffer, G buffer, yeah. Okay.
into the G buffer here. I would skip to the lighting pass so we can see the proper colors, but there's one very important draw call that we don't want to miss. Event 794 draws the helmet we see in the screenshot. If we check out the model data in the frame debugger,
so it
then we
actually
can
is a physical object. Cool.
confirm this is in fact
Hey, Phil,
the
good morning.
visor of the helmet the player model wears, and it's not faked with a shader as a post-process, which answers one of our earlier questions, and now we can move on. Before we can do lighting, Unity needs to do all of its shadow mapping and HDRP fancy expensive lighting pre-calculations. This takes about 8,000 API calls, which means about half the frame time is spent on the fancy volumetric lighting we see in our screenshots. I'm not going to explain how the volumetric light works. If you're interested though, the logic is very similar to the techniques presented in my Counter-Strike 2 smoke video. If you recall from that video, this stuff is very expensive, but this expense is clearly worth it as Lethal Company makes heavy use of volumetrics as a gameplay mechanic, mainly for obscuring vision both in the dungeon and on the surface. After Unity has finished pre-calculating the lighting, then the deferred lighting pass executes.
I wonder if this only works with RTX cards. It doesn't, right? It works with every card. I've never done volumetric lighting, so I have absolutely no idea how that's done. But it looks like it's trying to like illuminate an area from multiple angles, right? And then you can figure out how thick something is. Every graphics card can do that. I see. Would be cool to implement that for fun, you know. I wonder how he did it in his own engine. That's something we could watch next,
have their
maybe.
lighting drawn, then Unity draws the skybox in, and then composites the frame with the volumetric fog. This lighting shader isn't anything proprietary either. It is just HDRP's default physically based lit shader, so it ends up not being too different from a simple Lambertian diffuse that I've discussed in previous videos. The frame at this point is pretty interesting. This is what Lethal Company would look like without any of its stylistic effects. This is surprisingly very useful information.
It actually looks really good, in my opinion. This looks quite nice. I already like this. It gives like an old game effect. Rob, thank you very much for following, bro.
Is drawn with realistic lighting first, and then it gets stylized, meaning that at this point, everything is post-processing, which is my specialty. How convenient. This independent stylization is the first and only proprietary aspect of Lethal Company's rendering, which means the developer made it themselves, and I have to figure out how it works. Great! The name of this shader is Posterization Filter, and it was made with Shader Graph, Unity's node-based shader editor. The name gives us a pretty big hint of what's going on. Like I said earlier,
so it's basically he's trying to create a poster effect. Postcard effect, something like that maybe.
Obvious quantization going on, and posterization is kind of just another word for that. If we take a look at a before and after though, there's clearly more than just posterization. We've got the edges in this pass as well, and if we take a look at the shader assembly, there's a lot going on. So, we've got to figure out at least two things ourselves. What's being posterized, and how are edges being detected? For the posterization, it's going to be easier if we swap to a different frame capture. Somehow, even though we're not outside anymore, this capture takes nearly 20,000 events to fully draw, which is interesting. This is because a ton of time is wasted drawing things that aren't even in view, which should probably be fixed, but that's not really the point of this video.
That's Unity, guys. That's Unity. Okay.
So let's move on. It took me a little bit to figure out what's going on here because Lethal Company is pulling a dastardly trick. Normally when you posterize something, you posterize the colors, reducing the amount of allowed colors to a much smaller amount. The smaller amount of allowed values, the more prominent the compression artifacts become, resulting in these blobs of color because there aren't enough colors to close the gradients. For some more info on why this is really useful and not bad actually, you can check out these two videos of mine. We see similar artifacts in our Lethal Company frame, so you might assume it's color data being quantized as usual, but no. If you take a closer look, you can actually see color gradients, so colors are not being compressed. Instead, Lethal Company is quantizing the volumetric lighting data and applying it again. That's right, Lethal Company is making the most of its expensive shader effects by doubling up on their results. First,
how old was this kid, by the way? How old is this guy? What the fuck? I thought it was some kid. This guy here? Wait, isn't this Lethal Company developer? It's not this. Isn't this Dream? He didn't make the game. This is Dream. This is not the developer. What is wrong with Google? Is Google trying to brainwash me? Wait a minute. Lethal Company fandom. Date of birth. This guy is... Wait. 22. You can't be that smart at 22. He's made... Guys, this guy has made games in Roblox. Now, if you take care of your kids, right, and make sure that they don't get harassed by older people in Roblox, and they find the correct Roblox point where they can make games in, Roblox is evil. Yeah, look how evil it is. I mean, I know what you mean, right? But if you take care of your kid... Look how they... I mean, the picture is a little bit unsettling, but look how they can turn out, bro. Look at this. This is incredible. This is really crazy.
In a realistic way, and then in a stylized way. That's why the floor here is noisy. The volumetric light data is noisy, so when it's quantized, the noise gets exaggerated.
Damn.
But Rolla, what about those weird squiggly lines on the wall?
What is
That
that?
kind of looks like posterization. I thought that too, but it's actually a second edge detection. When we take a peek at the dreaded shader assembly, we can see that the shader is doing two neighborhood samples, one of the depth buffer and one of the color buffer. The simplest method of edge detection is by calculating the
Hello,
local
Theo.
maximum contrast of a pixel, that is, the largest difference between neighboring pixels. If this contrast value exceeds an arbitrary threshold, then an edge exists there. The contrast value is usually calculated with depth or normals, which Lethal Company is doing for one of the edge detections, but it could technically be done with anything, like color data. The problem with that, though, is colors are 3-component vectors, so we need to reduce it to a single value, either by only comparing one of the 3 components, or calculating some value like luminance or saturation. The answer to which method Lethal Company is using is somewhere in the shader assembly, but I don't get paid nearly enough to interpret that for you beyond a basic level. I'm just going to assume it's the luminance of the color, because that's what I would do. Beyond the light posterization and double edge detection, there's not much else to the main stylistic pass of Lethal Company, but the effect that comes next might surprise you a bit. In case you forgot, the black shapes on the border of the frame is the visor of the player character's helmet. Normally, something this close to the camera, or even your real-life eye, would be out of focus. But since our game camera is not a real camera or eyeball, it's instead fully sharp, like everything else in view. What is a shader effect we could use to simulate camera or eyeball focus? That's right, depth of field. Lethal Company makes use of Unity's absurdly expensive depth of field shader to blur the helmet.
You know what I hear from this video over and over again? Unity's rendering is dog shit. That's what I hear every time, man. Everything's expensive, everything's slow, it's not supposed to be used, 20 FPS, way too many draw calls that should be cancelled before even sending them to the GPU. Like, my man, they're doing a good job, bro. Holy. And he's still getting 120 FPS, yeah. Crazy.
Which is funny because this shader effect is one of many things that could be entirely responsible for Cities Skylines 2 running so terribly. The depth of field is calculated right after the posterization pass, giving us the blurred helmet visor, and will also slightly blur held items. I think it's really funny that something so expensive is being used for something so easily faked, but again, Lethal Company gets away with it because of the very small render resolution. After depth of field, we have the 1-2 combo of shader effects all gamers love to complain about, bloom. Bloom is fairly straightforward. You separate the bright pixels, blur them, and then add it back to the original image.
Exactly.
But we don't only have
you blur them, scale them down, and then but basically
bloom here. Unity is doing the right thing and condensing a whole lot of final tweaks into one mega final pass called Uber Post. Most of the time, we'd be out of luck with this pass like we were earlier with the posterization pass, and would have to figure out what's going on ourselves. But thankfully, Unity actually has the shader code for all their shaders on GitHub, which is an insanely valuable resource. The Uber Post compute shader does a whole lot of effects in one big pass, these being lens distortion, chromatic aberration, bloom application, vignetting, color grading, post-exposure, and gamma correction. Lethal Company is pretty clearly only using the bloom, post-exposure, and maybe the color grading to make it more saturated. After this pass, the UI is drawn, and gamma correction is applied before the frame is presented to the screen, and we have successfully drawn one frame of the game. With all that finished, let's do a quick recap. First, all the objects in the scene are drawn and realistically lit. Unity's atmospheric scattering simulation is composited with the image to create a realistic fog. The developer's custom posterization shader is applied next, drawing edges based on depth and some mystery color difference, and then applying a second layer of volumetric light, but thresholded to create a posterization effect. The helmet visor is blurred with Unity's HDRP depth of field shader, and the frame finishes with bloom, as well as some final color corrections before being upscaled to fit the screen from its low fixed resolution, giving it the pixelated aesthetic. Despite being an ultimately simple stylized rendering pipeline, Lethal Company's visuals are compelling, and I hope it can serve as—
It's not actually simple. Like, it is simple, but in the grand scheme of things, if you like think about what actually is simple, just drawing an object and moving, you know, without any lighting interaction, it does a lot of work. It is really, he spent a lot of work on the aesthetics.
It's a point of inspiration for people that think these realistic effects can only be used for realistic graphics, or that they have to know shader programming to make an interesting looking game. As usual, thanks for watching.
I think this effect right here,
HDR thresholds and the atmospheric—
I think this already looks nice. This gives like an old game vibe. Looks like old Halo. Yeah, something like old Halo, right? Very nice. That was very interesting. So maybe it's possible for us to do something like that too in C++. I would be interested. Like, I think whenever we switch over to 3D, you know, once I'm done with my 2D game, maybe like in a year or two from now, I know it's gonna be a long time, I feel like experimenting with these types of things first before we dive into actually making a game. And then we find out a cool style for our game that we can then apply, right? Of course you can do that. Yeah, you can do that in C++. Probably more efficient as well. Do it in Vulkan. Of course that message is from Travis Roman. No, man. You know how much work that is, bro? Absolutely not. You know how long it took me to add just Bloom into Vulkan? No way. Yes, actually I do, yeah. Exactly, he does. I know he does. Alpengel is the same work. You're wrong, you're wrong. It's good. Okay, bro. Yeah, it's like from someone that hasn't been using Vulkan for a while. Of course. Code and agree. Sure, brother. Anyways, cool video, really cool video. Very informative.